All right, we're going to be calculating force vectors on the coordinate grid. The first question I always ask is what quadrant is each of the vectors in? So if you look at force A, you can see that is in quadrant 1. And if you look at vector B, you can see that is in quadrant 4. And the reason why I pay attention to that is because it will tell us what the types of numbers we'll be dealing with. So in quadrant 1, X is going to be positive, Y is going to be positive, and then in quadrant 4, we're going to be dealing with a positive X value and a negative Y value. So that tells us those right away. After that, we're going to go ahead and break into right triangle trigonometry. And we're going to do that to find our horizontal and vertical components of each one of those forces. So let's go ahead and look at force A first. Okay, if we look at force A, I'm going to break it into a right triangle. I'm going to go ahead and start looking for the vertical component, or Y. I'm going to look for the horizontal component, which is X, and then I'm going to label that my hypotenuse is 75. Now, as we do this, it is right triangle trigonometry, so pay attention to those sides. So from 45, Y is the opposite, and from 45, X is the adjacent. And you'll notice that there's a little bit of alignment. From 45, we're going to use adjacent over that hypotenuse, which is going to be cosine. So I'm going to write cosine of 45 equals to X over 75. And then I'm going to go, in order to find the Y, or the vertical component, I'm going to use the opposite, which means we are going to use sine. So I'm going to say sine of 45 equals to Y over 75. Now we're going to go to force B. We're going to do the exact same thing. You'll notice in this case, the hypotenuse is 63. That is our force of 63. And the angle is going to be 75. And then from there, we're just going to label our X and our Y. I'm going to go ahead and scribble this 75 out because that's showing the angle. I'm just moving it closer in. Okay. So once again, X is the adjacent. So I'm going to write cosine of 75 equals to X over 63. And I'm going to go to the Y value. I'm going to say sine, because sine of the Y is still the opposite. So I'm going to write sine of 75 equals to Y over 63. Now, the only thing we need to do at this point is make our calculations. So I'm going to come over to Desmos. I'm going to type everything in and solve for X and Y in each one of them. Okay, so, well, check it out. We've got our first one that is already set up. Right here, there's the force A, and then what we have is force B already accounted for and solved for. You'll notice that there is a negative on the sine 75, 63. This is the Y component, and remember the Y in quadrant 4. Remember, we should have a positive and a negative, so that negative is getting shown right there. Okay, so I'm going to go back to the class cake, and I'm going to write down those values. This was 53. So we had 53, 53, and then let's go back, and we had 16 and negative 60. Okay, negative 61. So 16 and negative 61. And I'm just rounding to the nearest whole number for ease on this. Okay, once we've got that, we've got all of our components. We're gonna work it down a little bit, and we're gonna put them into a table, because what we want to do is we want to combine the two vectors. And how we're going to do that is we are going to take force A, we're going to take the X and Y component. So force A's X and Y component was 53 and 53. So I'm going to write 53, 53 into the table. And then force B's were 16 and negative 61. So I'm going to write 16 and negative 61. Now, in order to combine these forces, all we're going to do is we're going to take the two components, the X components, and we are going to add them together. So I'm going to come down here and we'll write 53 plus 16 and 53 minus plus negative 61. So let's go back to Desmos. We type that in. So I'm going to get 53 plus 16, which is going to be 69. Okay. And then what we've got is we're going to do 53 minus 61. Okay. And we're going to do 53 minus 61. And that is negative 8. And these are what we're going to be using, the resultant force components, or what we're going to be using to find the magnitude of the final force. So let's use that information. It says, sketch a graph of the resultant force by using the resultant force components. Label the graph with the position vector and label both the x and y components. So we have 69 and negative 8. And we're just going to be making a sketch, nothing too fancy. So what we'll do at this point is I'm going to draw the y-axis, the x-axis. And we know that what we're doing is we're going to the point 69, negative 8. So that's all we're going to do is we're going to sketch that out. So I'm going to go out, let's change our, maybe change the force color to green. And we're going to go out 69. So let's go 10, 20, 30, 40, 50, 60, 70. So it's right around there. And maybe we'll just drop down a little bit. 2, 4, 6, 8. Just, I know that scale is not great, but we'll go here. And I'm going to draw that out here to that point. Okay, and it does say write it as a position vector. So we can write 69i plus negative 8j. Okay. Now, what we're going to do is we're going to find the force vector on that, or the magnitude of the final force. So I'm going to take the information I have and I'm going to label the horizontal component, which is 69. And I'm going to label the vertical component, which is negative 8. And we're going to find the resultant force, or the magnitude of the resultant force, which is there. Notice that we have a right triangle, and that is just simply the Pythagorean theorem. So I'm going to write 69 squared plus negative 8 squared in parentheses equals to equals to c squared. We'll use that since it's the Pythagorean theorem. Okay. And I'm just going to go over to Desmos and type all that in. So 69 squared plus negative 8 squared, which is 4,825. And we're going to take the square root of that, 4,825, which gives me 69.46. And that will be our result, 69.46. Let's just use 69.5. We want to show that it is longer, even though that it's not much bigger, just because it is the hypotenuse. Okay. And then it says use right triangle trig to determine the angle of the resultant force with respect to the x-axis. So we're going to do that with respect to the x-axis. So we want to find this angle right here. Okay. That should be fairly easy because we're just going to be doing right triangle trigonometry again. And we can use anyway. We can use tangent, sine, or cosine since we have all three sides. I'm going to go ahead and use cosine. I'm going to say cosine of the angle. We'll call it theta. Let's call this theta. Equals to adjacent over hypotenuse. The adjacent is 69. The hypotenuse is 69.5. So 69 over 69.5. Okay, and we're just going to use the inverse to find that angle. So 69 over 69. And go back into Desmos, type it in. And it is 6.87 or 6.9 degrees. So we're just going to come over here. We're going to say, okay, well, it is 6.9 degrees. With respects to the x-axis, but we'd say it's negative 6.9 because it is going in the opposite direction as we go around the quadrant. So negative 6.9 degrees with respect to the x-axis. There it is. We found the magnitude of a resultant force, and we found the angle in which it is moving in direction of the x-axis. Hopefully that helps you out in the case that you needed some extra steps in order to do this.